what it is. Now, okay. Now we come to distribution of electrons in the shell. Okay. What is the formula that we'll use to find out the distribution? 2n squared. Correct? But when we are distributing, did I tell you what page number I'm talking about? Satwik, your mind is very different and it's difficult to handle you, okay? Every time there is a complaint about you, and I believe that the complaint is really genuine because I see the way you behave in my classroom. Your duty now is to pay attention to what I am saying. If I tell you, open your textbook, I will give you the page number. Don't disturb my class and don't disturb him also. Now, when I tell you the atomic number is so and so, you will distribute it in the orbitals. You have to remember what? The 2n squared rule. Correct? You also have to remember the duplet and the octet rule. What is the duplet rule telling you? That you should have only 2 electrons in the first shell, full stop. And the octet rule says you have to have 8 electrons in the valency shell or in the last shell. 8 electrons. Okay, so when distributing electrons in their orbitals, you have to remember 3 things, which is the first thing you have to remember. What is the first thing that you have to remember? First rule that you have to remember. Ian, what's the first rule that you have to, first thing that you have to remember? Huh? First rule that you remember. You, first thing you have to remember. Huh? What is the first thing that you remember? The 2n squared rule. Who said that? You have to remember the 2n squared rule first. Then you have to remember the octet rule, the duplet rule, and then the octet rule. Okay? So now, suppose we have your, say for instance, calcium, and the atomic number, means number of electrons, is 20. Correct? Now, generally speaking, if this is an even number, the atomic number is multiply this by 2. Atomic weight. This is the atomic number. The atomic number is even. Atomic weight is directly double. Generally speaking, there are always exceptions to the rule. If the atomic number is 13, if it is odd, it is multiplied by 2 plus 1. That is 26 plus 1 is 27. If it is odd, it is multiplied by 2 plus 1. If it is even, multiplied by 2. What are we to multiply by 2? Atomic number is to be multiplied by 2 if it is even. And if it is odd, multiply by 2 plus 1. Now, we have got here you don't want this. You don't want this also. Now we want to arrange your calcium. It's 20. So therefore now, if 20 is your calcium, your protons also will be 20. Protons will be 20. So if 20 is the protons here, what will be the weight of the nucleus in? If 20 is here, what will be the weight of the nucleus? 20. Why 20? Cut. Protons and neutrons. So therefore it's double. So it became 40. Followed? Anyone? Any difficulty here? Any doubt here? Now we have to arrange the 20. Remember the 2n square rule. 2n square rule. The first one is 2 into 1 into 1, 2 electrons. Correct? So you have got only 2 electrons. Put them together in pairs. Not here anyway, put them in pairs. Second one, second rule that you have, second one is 2 into 2 into 2 because n is equal to 2. That will be 8. 1, 2, 3, 4, 5, 6, 7, and 8. So that means how many have you already accommodated now? 8 and 2, 10. You've got to add 10 more. So the third one is here. Third one is here. That is 2 into 3 into 3. This is K, L, M shell. That's equal to 18. Correct? But we have got to do only 20. We have got to do only 10. And this can accommodate 18. But we have got only 10 left. Correct? So we put that 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. My shell is over. Now, according to the duplet rule, I should have 2 electrons in the first shell. Yes, I got 2 electrons in the first shell. I am supposed to be having 8 electrons in the outermost shell, and this is my outermost shell. I am having 10. Wrong. So therefore, I don't have to put here. I'll take another shell and I will put here. 2 will go on to a new shell. Correct? All right. So that means this is the valency shell. It has got 2. You need how many? 6 more to make it stable. Is it easy for it to accept 6 or to give out 2? So it will give out these 2. And this whole shell will get cleared out. And then this only will remain. This is stable, this is stable, this is stable. For an octet rule, octet shell, the valency shell, and the 2 extra were given out. When this is given out, the shell also disappears. And what remains is a stable atom. Stable atom, correct? Now, you know what an atom is? What is an ion? Have you heard of this word ion, ion? We would say that an atom is electrically neutral, or atom has got no charge. What is an ion? ion, ion.
Ions are charged.
How it will get charged? Yes, you're right. Ion is a charged particle. Don't pull out the skin from your lip for heaven's sake. Ion is a charged particle. You're right. How? From where did it get the charge? How is it? From where did it have it come? Yeah.
If it gives 8 or shares electrons.
Who's it? I or you?
The atom.
You.
Like when an atom donates electrons, the number of protons is more than electrons, so it gets positively charged.
When it did donate. Yeah, you're right. You're very absolutely right. So, for instance, an atom is electrically neutral, right? Electrically stable, but chemically it's unstable. Why? Because it does not have 8 electrons in the outermost shell. In order to acquire that stability, it has to either accept electrons or give out electrons to get 8. So when it gives out electrons, number of protons become more. The balance of equal number of protons and equal number of electrons is gone because it gave out 2 electrons. Correct? And became stable. It became chemically stable but electrically unstable because protons, the positive charge, became more than the negative charge. So now this atom has got a positive charge. We cannot use the word atom has got a positive charge. Atom is always electrically neutral. So the word atom has to be changed to ion. An atom with a charge is called an ion. Ion is positively charged. And that particular atom which accepted the 2 electrons, okay, it got more negative charge and less proton and less positive charge because it accepted 2 electrons. Right? So it became negatively charged. So it became a negatively charged ion. Positively charged ions are called anions. Negatively charged ions are called cations.
Not negatively charged ones are called anions.
Negatively
Yes,
charged, sorry, positively charged,
Positively are called cations and negatively are called anions.
one moment.
Yeah, cations are positive. Yeah. Yes, cations are positive and anions are negative.
Children, please listen to me. I'm not an idiot. And if you open your mouth, I thrash you. Because whatever you got in your head is wrong. A positively charged ion is called an anion. A negatively charged ion, so a negatively charged ion is called a cation. Cations go to the cathode. That's why it's called negatively charged go to the positively charged ion. Cathode. That's why they're called cations. Oppositely charged poles attract each other. Yes or no? Yes or no? See the mistake that you're making. What? Huh? Because it's okay. For the moment, just leave it out. Just leave it as it is. Just leave it. That confusion. Just rest. I'm also getting tired. I'll explain it to you very clearly. Remember one thing: oppositely charged ions will attract each other, right? Okay. Pay attention. Positive means addition, adding. So anion. Add. Anion. Positive is an. But the positive ion goes to the cathode. And there on the cathode, it acquires the positive charge and becomes positively charged. That is an electrolysis, which is not there for you. But remember this. I'll explain it to you next time when I come. Is this clear? Follow? Remember, anions add. Adding means addition. Anion. Cathode is negative. Cathode is a negative pole. Anode is the positive pole. Yes or no? Yes or no? That you remember in your head. This basic you remember in your head. Cathode is the negative pole. Anode is the positive pole. That's what you remember. Anion, add. Positive. That you remember. Rest of it, I'll explain it to you when I come and take out that confusion in your head. That is the ion. Okay, so now you got now what is even same thing. Again, I will make a mistake. Again, I will going to make a mistake, and it may be another confusion thing. A concentrated acid is very strong, and a dilute acid is weak. Wrong, children. Wrong. When we go to the 10th standard, I'll explain to you. But till now, I will tell you. A concentrated acid. Now, this is outside the textbook. Huh? It will come to you next year. A concentrated acid has got more of acid and less of water. And a dilute acid has got more of water, less of acid. That's what you got confused. Okay, now what actually happens? Suppose I take hydrogen gas and chlorine gas and mix them up together. I'm getting hydrogen chloride gas. Clear? I collect that gas, I condense it, take out pressure, Take out temperature, increase pressure. Take out temperature, increase pressure. I got hydrogen chloride liquid. Correct or not? Okay. Now, if I take a litmus paper, red litmus paper, blue litmus paper, and put in that hydrogen chloride liquid, what will be the observation that you see in that litmus paper? If I take that red litmus paper and put it into a HCl liquid, what will be the color change, if at all there's a change? If I put a blue litmus paper in it, what will be the color change, if at all there's a change? Blue will turn to red, and red,
Red. Red will remain red.
and blue will turn to red. Wrong. This is talking nonsense. This is chemistry or bullshit. Because that is HCl liquid. I use the word liquid. And the HCl liquid is neutral. Is neutral. Now what happens, I'll tell you. It is neutral. Have you ever heard your teacher say, when you are using these indicator papers, litmus paper, moisten it, moisten the litmus paper. Don't use dry litmus paper, use wet litmus paper. She says that or not? Are you sure or am I talking nonsense? She said sure, correct? Why? I'll tell you the reason why. Now, HCl has got this bond. Correct? This was your HCl liquid. That HCl liquid in which you put your dry litmus paper. Red remain red, blue remain red, blue. That means HCl is neutral. Now I'm adding water to it. The water has come from the water to it. The water has come from the litmus paper. I told you this bond is very, very strong. This bond went and broke this bond. This bond broke this bond. And what you got? You got 3 hydrogen ions, you got 3 chlorine ions, and you got your water. And you got this water. Correct? Now this hydrogen ion cannot live alone. It will come very nicely and join water, and this water will become H3O. Okay? ये इसके साथ शादी करता है. And it will become hydronium ion, and this positive charge it will give to this hydronium ion, and it becomes its dowry. So this will become hydronium ion, and ये इसका dowry है. So water which had no charge now has become hydronium ion, which has got married to hydrogen ion, and hydrogen ion brought its dowry and gave the charge to it. This is the hydronium ion. This hydronium ion is responsible for the acidic properties of acid. Now, if you put your litmus paper inside, you will change. The red will remain red, and blue will become red. It's the free. This hydrogen, as long as it is locked up with HCl, will not show its properties. As long as I'm in the classroom and I've blocked all you out properly, you will not show your correct properties. The moment I leave the class, all of you will show your true colors. The bond has broken. Would have run away. I've gone out of the classroom. Same thing here. As long as it is locked up here, it will not show its properties. The moment this has gone and broken the bond, the hydrogen has become free and it's showing its properties. It has become hydronium ion. Correct? That's one point to remember. Second point to remember is all acids must contain hydrogen. HCl, HNO3, H2SO4, H3PO4, H4PO4, H3PO4, all of these, HBr, HCl, HNO3, all of them must contain hydrogen. It is that hydrogen that gives you the acidic properties of the acid when that hydrogen is free and it becomes hydronium ion. Is this clear? Is this clear? So now, if I take acid, okay, and I put it into water, the water has to break that bond and release large number of hydrogen ions in that solution. The large number of hydrogen ions will make a strong acid. If the hydrogen ions are not broken, the acid will be very, very weak. Correct? So now I'm coming back to my original statement. A concentrated acid is a weak acid or a strong acid. Huh? Why weak? Why do you say weak? Your answer is right, but why?
It's got less quantity of water.
Because the breaking agent is very less. The breaking agent, which has to break the hydrogen acid, is very less. Large amount of acid and little of water. So it's breaking only this much of hydrogen ions. So hydrogen ions release are very, very less. So that acid is weak acid. But if I take less of acid and more of water, breaking agent is large. It has given out large number of hydrogen ions. Large number of hydrogen ions means large number of hydronium ions. Large number of hydronium ions means strong acid. Followed? Now you understand the concept from literature. Concentrated acid is dangerous. Concentrated acid is very dangerous. No! A concentrated acid is not strong. It is weak. What's the concept now? Same concept you will have come from the class cation, anion. Get the concept very clear. You are learning things by heart, not realizing what you are learning. A concentrated acid is a weak acid. Why? Because there's large number of acid and less amount of breaking agent. Correct? While a dilute acid has got large amount of breaking agent and less amount of acid. But again, it should be liter per volume. I can't use this much of acid and 10 liters of water. That is stupidity. Then I will not have any acid on here. I can use 10 ml of acid and say about 30 ml of water. That will be a concentrated acid. Followed? Sorry, not a strong acid, not concentrated acid, a strong acid. And if I take 10 ml of acid and 2 ml of water, then that is a concentrated acid, okay, but it's a weak acid. Followed? Clear? What's the time now?
126.
Okay, so now did you understand? We come back to water, what were I talking about now? Ions, positive ions and negative ions, correct? And so what is a positive ion? A positive ion is an ion having large amount of positive charge, correct? Why? Because it donated electrons. And negative ion, okay, negative electron is not like negative ion is an ion which has accepted electrons. Okay, it has accepted electrons, so the number of electrons is more and number of protons is less. So it will become a negatively charged ion. Okay, followed? Okay. So I explained to you, correct. So I have explained to you. Okay. Now, since you have finished all that, you read from in your book right up to valency. If you are taking Selena, read up to valence electron. Don't read valence electron, read up to valence electrons. Okay, up to valence. And if you're taking Dalal, you read page 54, 55, 56, 57, and 58. Read all that. And then I'll give you some exercises on the board. Dalal is up to 58. On which page? 54 to 58. And Selena, you read up to valency. Hurry. You take from the volume. Take from the volume. Or you can sit with her, Selena, and read from her. understood what I explained to you so far? All of you have understood clearly? Huh? One moment. Go. Ian, I can hear you talking. I crash you if I come there.
Why doesn't proton attract the electron? Because unlike static attraction,
Why does?
proton not attract the electron.
See what happens is, the proton is locked up in the nucleus. Right? The proton is totally dominated by the nucleus. It is the nucleus that can attract the electron, not the proton. The nucleus has got no charge that can, sorry, the nucleus has got, what charge does the nucleus have? Positive. So since the nucleus has got a positive charge, which is given to it by the proton, nucleus will pull the electron. Right? But then what happens is, if all the electrons are going to be pulled and pulled and pulled by the nucleus, they will all drop into the nucleus and there will be no stability, the atom will break. Follow? The atom will break. Therefore, the electrons are made to remain in fixed orbitals, correct? Fixed orbitals within fixed energy. Like for instance, telling you now, suppose I am an electron and I've got my energy. My energy is closed within this classroom. This is my orbit. My energy is fully charged, or this room or this orbit is fully charged with my energy because the room is tight. The orbit is tight. But if you keep that door open, my energy will also go into the next classroom and the next classroom, and you find my voice getting very, very faint. Okay? That is the same thing happens in the case of an electron. It is fixed in that orbit and it cannot move out. It cannot be pulled and get into the center of that. It cannot. The orbit is shut and the room is shut. If the orbit was able to be broken, then the electron will drop into the nucleus and the atom will be unstable. That is your Bohr's atomic theory. You read Bohr's atomic theory, it gives you there. Bohr's atomic theory. And electrons will always move in a fixed orbital. Like I will be fixed in this classroom. This classroom is my orbital. This is your orbital. It's like somebody will go to 10 standard and that is his orbital. That is his mixing on his orbitals. because he's a perfect idiot and gets into trouble. And what happens when he goes to that classroom? He gets into trouble. Same thing will happen. If an electron jumps from its orbit and goes into another orbit, there will be a problem in the atom. Have you understood? Now you know why you have to stick in your own orbit or something? And you know, if you ever go to next classroom, I will trouble for you. Is this clear? Stupid boy. See, basically, when it comes to stability of physics, conditions behave like non-states. Hydrogen is not a metal, it is a gas, not a solid, it's a gas. Because it donates electrons, it behaves like a metal. And at times it accepts electrons, so it behaves like a non-metal. Its behavior of metal or non-metal is only pertaining to donation of electrons or acceptance of electrons. Nothing else. Physical properties don't change. In the case of metalloids, the physical properties changes also. Chemical properties also change. Follow? That's what they call metalloids. In this case, hydrogen does not change. It is always a gas. Its physical metal properties is only when it breaks. At that time, it becomes metal. And it becomes a non-metal when it accepts it. Only at that point, it is considered to be a metal, not a metal. At any temperature, they change. Whatever non-metal properties not necessarily changing temperature, this process. Why are you sleeping? Why that boy sleeping?
Yeah.
You're sleeping. Sit up straight. Huh? What is it?
He finished reading, so he's sleeping. He finished reading, so he's sleeping right now. Ma'am, we have to learn the mass number.
The
The mass number.
See, if you learn the atomic number, Then you know which order you
But
can.
because sometimes the mass number is like more from one or
One or two acceptance are there. That's right. So you have to learn up to calcium, up to 20, up to calcium. That's that one part. And then what are the questions in the back of the chapter? Are there any questions in the back?
yeah, I completed till
Complete. Continue writing down the question answers of the last of the previous chapter. Water, no, I gave you. Finish up water, no?
periods.
Selena, have you done the question answers from behind from volume?
No,
Class, that class work. Andrew, not Andrew, Ian.
yeah.
Do from university tutorials. Do the class work. Hurry up. Hurry up. If you finish sleepy, go and wash your face. Go and wash your face and Ian.
I will finish the from the water.
From water.
From the water. So it's not water. It is water.
Oh, again is making a noise.
Mommy.
Here, give him my knock on his head. Throw. Give him my knock on his head. Throw. Knock on his head.
I'm not suffering.
Come on, start answering all the questions. I'm not going to give you any homework. Do your homework in the classroom inside. Quick. Finish up all your homework in the classroom. talking something.
Not all these questions are the same. Not all. Same.
Those that they were from the
Sahi.
So then don't do them, no? These are from Selena only.
Oh.
So Selena book only. One more.
Yeah, I will read them.
Some random part.
It's a national one.
As what?
Subjects.
Pardon me?
They have the volume as well as the textbook. They have not given the advantage of soft form. But if it is
Artist is there, no?
no.
In the textbook is not there.
It's a Selena.
Selena is there. Selena is there. Selena. I don't need to.
It is used on beverages and wine.
Yeah, and
And it is very soft water.
yeah, soft water. Yeah, okay.
Soft water का दिया है. Soft water का भी दिया होगा. And nice.
It is nice. Hard water.
So water is not giving. For this. That's not there.
Oh, so that I do that. They do that particular ion exchange. That's not.
Yeah, maybe. Just but it was very good. It's good. Let's be joking and good. I am getting. No. Can we refer the book?
Yes, I have.
Are you talking, Satvik?
He was talking. He was pulling my
Who?
Yeah.
Give me my hand, it's wrong.
Yeah, when I'm turning around and if you make me a video.
Yeah. First you have to do your work on atomic structure.
What is the meaning of permuted?
Permutite, that I told you, leave it because that's not the ion exchange is not there for you.
No, explain the permuted method.
Permutite of hardening or of softening hard water, that's not in your course.
It's okay.
Leave it. I told you that's not in your course. It's there in Selena, but it's not there in your Delal. And it's not there in your syllabus also. What are you doing? You're looking at him and reading. Can you put the fans off, please? Fans off. Up, there. What happened? This is already cut off from there only, that's cut off. Are you not working out your work, your work? You're still reading only. Huh? Ian, you're still reading, Ian. Are you not writing down? Have you started writing down Saturday? This girl is still reading only.
No, I started writing.
Write it down, complete now. Hurry up. Huh? A substance whose solubility rapidly increases with the temperature. But NaCl. Read the textbook, you idiot. Huh? You want me to be your textbook and you answer immediately? Huh, lazy boy? You've got all the energy to go to the 10th standard class and make trouble there.
Stearic acid. Stearic acid.
Stearic acid. That is in soap and in detergent, but that's not there. You just remember that, I put sulfonic acid, I remember I told you that, SO3H, that I only gave you the mechanism, just for your information. It's not there in your course. What I taught you about washing of the clothes is only a general information. It's not in your course.
Here it is written C17H35CO.
That is the of soap, yeah.
So
Organic
every
part.
soap is like this only.
All this, it has got a positive charge and a negative hydrocarbon tail. It can be stearic acid, it could be any acid. Mostly stearic acid tail, because it's cheap. It refers from company to company. Companies don't tell you what secret they're using when they make soap.